let's review the prime and composite rules from yesterday and our divisibility. So the first example is 34. Is it prime or composite? It is composite. And why is it composite? Because it can be divided by 2. So there's my C divided by 2. 29, prime or composite? It is prime. And 111 looks like it's going to be prime, but if you add 1 plus 1 plus 1, you'll get 3, and if you remember that the sum of the digits means that it can be divided by 3. So 77, what is 77 divisible by? It is divisible by 7. 603, is it divisible by 2? No, it's not even. 3, 6 plus 3 is 9, so it is divisible by 3. 4, last 2 digits, nope. 5, no. 6, well, 6 is divisible by 3, but it's not even, so it's not 6, it's not 7. 8, it is not 8. 9, 6 plus 3 is 9, 9 can be divided by 9, so it's 9. And 10, no. The last one, 741. It is not divisible by 2. Go ahead and do the sum of the digits. 7 plus 4 is 11, plus 1 is 12, which means it is divisible by 3. And then it is not 4, it is not 5, it's not even, so it cannot be 6. And it is not 9 or 10. Page 158, 37 through 40. Do these in your spiral on your own. They are statements, and if it's true or false. So for example, 37, all even numbers are divisible by 2, and that is true. And finish 38 through 40. And then you can pause this while you work on that. And now we're going to take a look at factors. Factors that are numbers that multiply by a number to arrive at a product. So for example, 6 is 1 times 6 and 2 times 3. So the factors of 6 are 1, 2, 3, and 6. Now, I know that some of you might have done something that was called rainbow method, where you would write the factors out in this manner. So we're going to take a look at 18. And you might have written it out by saying 1, and the 18 way over here, and then you might have done the 2 and the 9, and then you might have done the 3 and the 6, and written them out that way. We're going to do things a little bit differently. We're going to set them up in a more organized fashion, because sometimes when we do rainbow method, we will forget factors. The work won't be as neat, and setting it up in an organized way is just going to be a little bit easier for us. So we're going to take a look at 18. So we know that 1 times 18 is 18. And we're just going to go in order. 2 times 9 is 18. 3 times 6 is 18. 4. Well, 4 times nothing will get me to 18. And then I'm going to look at 5. Nope, 5 won't go into 18. And notice that the next number on my list would be 6. And 6 is over here. So once I see that next number on the right-hand side, I don't need to go any further and try 7 or 8. So my factors of 18 are finished, and I'm just going to write them all down in this order. 1, 2, 3, 6, 9, and 18. Oops. Let's take a look at our factors of 24. We have 1 times 24, 2 times 12. Because 24 is an even number, we know that 2 will go into 24. 3 times 8. Divisibility rules, 4 plus 2 is 6. 6 can be divided by 3, therefore 24 can be divided by 3. 4 times 6. 5, nope. And the next number that we would write is 6, but because it's already written there, we're done. We don't need to check anymore. So we just have 1, 2, 3, 4, 6, 8, 12, and 24. Let's take a look at 48. 48 is one I like to do because when you do rainbow method, you end up skipping some. So we have 1 times 48, and we'll have 2 times 24. But what about 3? This is the one that most people will forget. Let's do the sum of the digits. 4 plus 8 is 12. Well, 3 goes into 12, so 3 will go into 48. Now, we might not know what it is, so we can just go after the side. And we'll find out it's 16. 3 times 16 are 4 times 12. 5 does not work. We know 6 times 8. 7. 7 does not work. And we're already back at 8. So we're done. So we have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. As we move on with these, we're not going to have to write these extra ones down, but this is just keeping you focused and keeping your numbers in order. Too often I have students with 48 will write 1, 2, 6, 8, 12, 24, 48. They might even skip the 4 and the 12. Lastly, we have prime factorization. Prime factorization is writing a number as a product of primes. Product meaning multiply, and primes meaning your prime numbers. The prime numbers that we're going to stick with right now will be 2, 3, 5, and 7. We will see 11, 13 come up, but these are the main ones that we're going to be using. You might have done prime factorization using a factor tree, where you might have written the number 12, and then you did 6 times 2. You might have even circled the 2, and then you did 2 times 3, and you circled all these, and you wrote down 2 times 2 times 3, or even 2 squared times 3. Now, so our factor trees, they can get a little big, a little broad. We're going to do something that's called successive division. It's going to look a little different, but it's going to be a lot easier. So what we're going to do is we're going to write the number 12. And we're going to make this, it's like an upside down division mark. And we're only going to divide by prime numbers. I always start with 2, even if 3 also would work. So 12 divided by 2 is 6. And then 6 divided by 2 is 3. And 3 divided by 3 is 1. And this is when you stop, when you are down to that 1. And then what you're going to notice is right here is your 2 times 3, or 2 squared times 3 is your product of primes for 12. Same answer as you had up here. It's just a little bit more vertical, a little bit easier to read. Let's take a look at 36. You'll see over here I've written down my prime numbers just to keep me focused. So 36, I'm going to divide it by 2. 36 divided by 2 is 18. I'm going to divide that by 2. 18 divided by 2 is 9. Divide this by 3. 9 divided by 3 is 3. And then 3 divided by 3 is 1. So we have 2 times 2 times 3 times 3, or 2 squared times 3 squared. And you can always double check your work. Let's go back. 2 times 2 is 4. 3 times 3 is 9. 4 times 9 is 36. So this is our answer. So I'm going to do 36 again, but this time I'm going to divide by 3 just to show you that it is going to work. So we can divide by 3. 36 divided by 3 is 12. Let's say you wanted to divide by 2 here. 12 divided by 2 is 6. 6 divided by 2 is 3, and 3 divided by 3 is 1. So you're going to get the same answer. Here's your 3 squared, and then here is your 2 squared. And thinking about the property that allows you to multiply in any order, commutative property, which is why we can divide by 3s or 2s, whichever one you want. Okay, last one, 54. Let's do 54 divided by 3. How do I know it can be divided by 3? 5 plus 4 is 9. 9 can be divided by 3, therefore 54 can be divided by 3. Well, you may be saying, well, I don't know what that is, so let's go off to the side. 54 divided by 3. 5 minus 3, we have 18. I know that can be divided by 2, which gives me a 9. Divided by 3, which is 3. Divided by another 3. And there's our 1. So we have 1, 2, 3 3s, which is 3 cubed, times 2. For homework, I want you to do page 163, numbers 1 through 4, which are the factors. And then I want you to find the prime factorization of 56, 27, and 64.